So I think you can get started.
Great. Go ahead and start with the screen share. Do you use, yep, I see my screen too. So again, welcome everybody to the Chicago Virtual MuleSoft Meetup Group. As President Jeet said, our topic today is a deep dive into Anypoint Runtime Fabric security. We'll start with the usual safe harbor statement. I do not believe we're going to be referring to any capability which is not currently generally available in Anypoint platform or in Runtime Fabric, but in case we do, forward-looking statements do apply. So from the perspective of the customer, as President Jeet mentioned, a lot of customers are taking a look at Runtime Fabric, whether they're going to migrate from an on-premise deployment, a hybrid deployment, or a CloudHub deployment to Runtime Fabric. So they're going to have a lot of questions about security with Runtime Fabric, what we do with our secrets, how we deal with properties at rest. Hey, wait, Runtime Fabric has edge security, has tokenization. How does that work? When should we use those? What else do we need to think about? And what's the most important thing we need to do to achieve security in Runtime Fabric environment? So hopefully by the end of this session, you will be able to answer all these questions. So by way of introduction, again, my name is Brian Statkevicus. I'm the MuleSoft Practice Manager at Big Compass. I'm based out of Denver, Colorado. I will have Connor introduce himself, and I will let you present, as I think the rest of it, the initial start is yours, Connor.
Thank you, Brian. All right, so as Brian said, I'm Connor Fitzgerald. I'm at Big Compass, and today I'm going to give a brief overview of Runtime Fabric, followed by an introduction to the tokenization service with a demo of the tokenization service. So what exactly is Anypoint Runtime Fabric? It is a container service that allows you to run Mule applications on customer-owned and managed resources while maintaining the centralized management provided by MuleSoft, or provided by the Anypoint platform. It's an appliance version of Mule Runtime that uses Kubernetes for orchestration. You have several different options for deployments, starting with cloud-hosted VMs such as Amazon or AWS EC2 instances or Azure VMs, as well as on-premise bare metal servers. And then MuleSoft added support for Kubernetes service providers such as Amazon, Azure, and Google. You can deploy consistently across your cloud or data centers. So if your Runtime Fabric exists within your data center, you're going to have much lower latency to your data. You can run multiple versions of multiple MuleSoft runtime versions in the same Runtime Fabric instance. You're going to have high availability and fault tolerance, along with zero downtime rolling updates across your replicas. And then just to reiterate that Runtime Fabric is still connected to Anypoint platform for management. So you're not going to lose any of those benefits provided by the control plane. So MuleSoft is aware that customers are standardizing Kubernetes as the key container orchestration platform for their application workloads. So what Runtime Fabric does is it allows you to own and manage your own runtime plane while the control plane still lives in MuleSoft Cloud. So you're not losing any of those benefits there. In 2018, when Runtime Fabric was first released, you could only deploy to cloud-hosted VMs or your on-premise bare metal servers. It did abstract a lot of the underlying Kubernetes and Docker framework away, so you didn't have to have any expertise or knowledge in those areas. But MuleSoft knows that a lot of their customers are using Kubernetes already for other application workloads, and that their teams do have Kubernetes expertise. So they began supporting in 2020 Amazon's Kubernetes service, as well as Azure's, and later Google. They're going to continue down this path with supporting the OpenShift platform, with the end goal being that Runtime Fabric can get deployed to any Kubernetes environment. So how exactly does it work? Again, there's basically two different variations. There's the appliance version, which is going to run on virtual machines, and then the Kubernetes version also obviously runs in a Kubernetes environment. With this model, the customer is going to own and maintain the hardware and networking, and then Runtime Fabric is going to be deployed on top of that. So MuleSoft, again, abstracts and maintains the Kubernetes stack, as well as handles the application deployments and updates. With the Kubernetes service approach, a customer has their own Kubernetes environment, which is going to be in the cloud hosted by, again, Amazon, Google, or Azure as of now. It's a bit more hands-on and involved on the Kubernetes side, where customers are responsible for provisioning and configuring their own ingress controller, which is basically the load balancer, as well as external log forwarding. So again, customers are responsible for maintaining the health of the Kubernetes environment, whereas MuleSoft is still going to handle the application deployments and orchestration of those. Getting into the architecture of the appliance variation, we have a controller node and worker node schema. For production environments, MuleSoft recommends at least 3 controller nodes as well as 3 worker nodes. Within the controller nodes live the internal load balancers as well as the MuleSoft agent. That MuleSoft agent is going to communicate back with the control plane to handle things such as the application deployments and updates, as well as log forwarding and the orchestration. If you notice, the application containers themselves run within the worker nodes. And it might be hard to see, but if you can tell, no 2 containers of the same application exists on a single worker node. This is configurable when you are deploying from Runtime Manager. So you can force these replicas to be deployed across your worker nodes, and that's going to give you that high availability and fault tolerance, where if a single container goes down, or you even lose an entire worker node, your customer is not going to see any downtime. With the Kubernetes approach, it's a bit lower weight. You still have a worker node architecture. Within those worker nodes are the ingress controllers, which again are provisioned and configured by the customer themselves. And then you have the agent, which is really only communicating with the control plane for deployments and updates of your applications. And then your application pods themselves are also going to exist within those worker nodes. Using the Kubernetes service provider installation, it is again a bit more involved and hands-on, especially on the Kubernetes side, but there are several added benefits, mostly the lower cost and less overhead. With the appliance variation, you're going to have to provision multiple controller nodes, multiple worker nodes, and those are each individual VMs. You're going to have to set up the networking between them. And the cost of hosting those controller nodes alone adds up on top of the worker nodes. Using a Kubernetes service in almost all use cases is going to be intrinsically cheaper than the appliance approach. Again, the appliance approach abstracts a lot of the low-level Kubernetes and Docker away, so you are left with less customizability there. But with the Kubernetes approach, you own the Kubernetes environment. You're able to fully manage and customize that, as well as the ingress controller and log forwarding agents. You have much more flexibility and control there. Getting to the comparison of the two, whether you go with the appliance approach or Kubernetes environment, you're going to be able to deploy any Mule application or API gateway there. Kubernetes and Docker are installed during the appliance installation process. With the Kubernetes environment, the customer manages their own Kubernetes environment, and then when MuleSoft installs Runtime Fabric, the Docker images are included. For the appliance variation, only Red Hat and CentOS are supported for your Linux distributions. The Kubernetes approach does support node auto-scaling. You do have to configure that with your provider settings. It's technically not supported with the appliance variation. However, there is a bursting feature. So when you're deploying an application from Runtime Manager to your appliance RTF instance, you're going to specify the minimum amount of vCores you want to allocate or guarantee to each one of your replicas. But then you're also going to set an upper bound, and that is the vCores it can burst to. So if you have a worker node with, let's say, 2 vCores, and you have provisioned only one of those vCores across your replicas, those replicas are going to compete or share, depending on how you want to look at it, the unallocated 1 vCore that is remaining. The RTF appliance installations include external log forwarding out of the box. If you have a Titanium subscription, you're able to forward those logs back to Anypoint platform. Otherwise, it's very easy to configure an external enterprise solution such as Splunk. With the Kubernetes approach, the customers are going to be responsible for configuring their own external load balancer, as well as their external log forwarder, as well as their internal load balancer, where again, that load balancer is included with the RTF appliance installation. However, you can configure an external load balancer to replace that if you would like. Continuing on with the comparison, the Anypoint Security Edge policies are not supported with the Kubernetes approach, but it is with the appliance version. And that's going to give you policies such as your web application firewall, DDoS protection, as well as IP whitelisting. Ops Center is a monitoring and administrative interface that is included with the appliance, but not included with the Kubernetes approach. However, through Kubernetes configuration, you can accomplish similar features. The persistence gateway is supported with both variations. And getting to our first trivia question, which of the following do self-managed Kubernetes RTF installations provide? I can't see the chat.
There's a few B's, a few A's, a few C's. They're all over the place.
The answer is C. And then I'll pass it back over to you, Brian.
Yeah, before you pass it over to me, Connor, I'll take the presentation. There was two questions that came up. The first question, is there any reference or documentation for Runtime Fabric using ingress controller or the Nginx ingress controller, for instance, Istio ingress proxy or AKS app gateway?
There is documentation for setting up the ingress controller in the Kubernetes environment. I'm not sure which ingress controllers it specifically provides, though, but I can follow up with that.
Okay. And the second question is, can you set a priority if more than two applications are competing for the same resource?
You can set that up in the Kubernetes environment as you have complete control over your nodes there. You can't necessarily set up the priority of a certain replica with Runtime Manager, but you can accomplish similar functionality through that minimum allocation as well as the burst limit.
Great, awesome, thanks. So I will go ahead and share my screen. Thanks for the introduction, including the discussion about the relatively recently supported Kubernetes engine support. So what I'm going to do is talk about Runtime Fabric security. So I'm going to approach it basically from I'll say top-down approach. I'm going to start with the network, because if you don't really secure your network, what's the point? Everything else is good. That's the most important part to secure. Then I'll focus on how you're securing your APIs deployed to Runtime Fabric, talk about securing credentials, and finally, I'll turn it back over to Connor, where he will talk about securing your data through the tokenization service. So as far as securing a network, this is the diagram that Connor just showed us. The recommended network configuration by MuleSoft for the appliance version RTF is to have 3 controller nodes and 3 worker nodes and an external TCP load balancer. So in the example that we're given here is you have a request coming in from the outside world. It goes to your TCP load balancer. Your load balancer, of course, is opening 443 for HTTPS traffic. The TCP load balancer finds an available internal load balancer on the controller node, routes the request there, in this case going to the middle control load balancer. And then that's going to go ahead and find an available worker, in this case app2. It's going to have the ping endpoint. It's going to respond to pong, go back to the internal load balancer, back to your TCP load balancer, back to your back to the original consumer. As you can see in my worker nodes, I do have duplicate apps, or cloned apps, I'm sorry, on different worker nodes. And you may also notice that all these nodes are on the same subnet. This is the recommended configuration just for a more simplistic network and also for latency. There are certain customers which will require a public and a private subnet model. That's of course allowed and supported. Just be aware that if you do set that up, you'll have to deal with network latency issues. Again, as far as the best practices are concerned, some of these are pretty obvious. Only expose the IP addresses that you really need to expose to the outside world. The same thing goes with ports. That's pretty self-explanatory. Again, use the external load balancer so that you can configure your ingress communication to only accept requests from a trusted source. In this case, that would be the external load balancer. Again, this is all documented very well by MuleSoft as far as network security best practices in setting up Runtime Fabric instance. So I'm going to go from network to start talking about API security. So for those of you who follow American football, you'll notice that they're starting preseason. Preseason will start regular season. And you'll see instances where it's short yardage, the entire defense is at the line of scrimmage. That works great, except if somebody gets through the line of scrimmage, then there's no stopping the running back, wide receiver, quarterback, whoever it is. They're gonna go score a touchdown. Similar analogy with overall security. You can have a single layer, but if the attacker gets through your single layer, there's nothing to back it up to counter any flaws. So that's why the general recommendation is multiple layers. Each layer has a backup layer to counter any flaws or gaps. Again, it's generally superior. However, just be aware it can be costly. Like for example, if you're using MuleSoft's API Manager for the gateway, you have another solution for your WAF, and then I'll talk about the Zero Trust implementation. Now you're starting to talk about 3 different components from potentially 3 different vendors, which means 3 different cost components. So it can get a little bit more expensive. And finally, again, the more layers you have to consider the performance impact to that. So of course, it's a trade-off. So we'll go ahead and discuss the layers. The first layer, of course, is the API gateway, which is going to prevent the brute force attacks. I've listed the most common gateway security measures that you will have here. Of course, this is implemented by API Manager within MuleSoft, again, designed to thwart the brute force and other simple attacks. The second layer is a web application firewall, or a WAF, or sometimes also referred to as a RASP, which is a runtime application self-protection. This is going to go ahead and protect against the OWASP's so-called top 10 attacks. I know OWASP last updated their top 10 about 2 or 3 years ago. I've heard they're going to be updating it this year. I haven't seen any updates yet, but it'll be interesting to see what sort of modifications have been made. So when you combine a WAF with the API gateway, you can go ahead and defend against other top 10 attacks, such as SQL injection. Obviously, the best way to thwart a SQL injection is to have a parameterized API. Don't let raw SQL in. That can still be worked around, but that solves 90% of the problems. And of course, there's other types of threats that can be handled by a WAF. We will talk about the Anypoint Security module, which supports RTF and acts as the WAF for RTF. Of course, there's other WAF vendors such as Azure's Front Door WAF. And finally, the third layer is the machine language or AI security engine. This implements what we call zero trust security. So for example, we have a person that works with us here at Big Compass. She's our event and marketing coordinator, Stephanie. She's actually very nefarious. So she's stolen, let's say in the use case, she's taken Connor's credentials. And Connor has valid credentials to go ahead and access employee information at your enterprise. Now, Connor may go ahead and generally just do one query at a time. Well, Stephanie's going to get all the information because she's very, very nefarious. What's going to stop her from doing that? She's presenting valid credentials. She's using the API as intended. So Gateway's not going to pick it up. WAF's not going to pick it up. The backend information is going to say, oh yeah, this person's authorized to go ahead and access employee data. What's going to catch what she's doing? That's where this ML AI security engine comes into play. What it does here is that it would actually pass the request through, because that's fine, but it would see the response and it would say, wait a second, this is not appropriate behavior by Connor. I'm going to go ahead and flag that. I'm going to go ahead and reject it as return. So that's where that's how you implement zero trust security. Within MuleSoft, you can develop a custom policy to do that. We here at Big Compass have developed a few custom policies for some of the vendors. I will show you an example of one of those when I get into my demo. So again, the AI security engine is going to go ahead and really thwart authenticate access attacks. So basically prevent nefarious Stephanie from doing something harmful to your environment. I mentioned earlier about Anypoint Security. Anypoint Security is here to provide edge security to the Appliance Runtime Fabric solution. So it basically acts as a WAF. I will demonstrate that. It can support denial of service, other WAF top 10, I'm sorry, OWASP top 10 attacks. And also you can provide a whitelist policy here. View the edge security as a global policy. So that's going to apply to all your APIs which are deployed within your Runtime Fabric instance. Of course, you can provide API policies specific to each application, like, for example, throttling, whitelist, custom policies, etc. Again, this does not thwart MLAI types of attacks. You'll need a third party to do that. And this is not currently supported on the Kubernetes engine deployments. So I've talked about API security. I also talked about network security. So I will go ahead and talk about encrypting properties at rest. Many of you are familiar with this concept. Basically, when you're accessing any enterprise information system, which could be Salesforce, it could be a file, it could be a database, these systems all need credentials. A common solution in integration deployments, or a common approach to this problem with integration solutions, is to use what we call service accounts. So these service accounts are basically provide for the integration solution. They may require routine maintenance. I've seen customers that change the passwords every 90 days on these accounts. You definitely want to secure those credentials. Some other customers are going to require that you secure some other sensitive information like URLs, IP addresses, client secrets, etc. Putting these in plain text is just not a good practice. You'll fail a security audit. You may be subject to Sarbanes-Oxley incidents. So it's just a bad practice. Fortunately, MuleSoft provides a few different ways for us to solve this problem. First one is what we call secure configuration properties. Many of you are familiar with this. You download the secure properties file, jar file. I have the link to 4.2. I'm sure there's a 4.3 version. You download the secure properties configuration. You have the ability to go ahead and configure individual properties or a whole file. If you want, supports YAML or .properties files. You will have to provide the decryption key as a command line parameter, and it's simple to access these properties. And I will demonstrate that shortly. The other solution is to use a concept called safely hidden application properties. This is supported in CloudHub and also in the hybrid deployments. You go ahead and configure which safely hidden properties you want in mule-artifact.json. And it is a really, really, really good idea to actually inject these properties as part of your CD implementation. So never even give QA or production properties to developers. And I'll talk a little bit more about that. However, for Runtime Fabric, it doesn't work the same way. As I will show you in my demonstration, you can have hidden properties in your mule-artifact.json file. However, they show up as plain text within Runtime Fabric. So the solution for that is to go ahead and create secure properties using the RTF CTL command line tool. However, as long as you have access to the property, especially the environment ID, and say, hey, I want to go look at all the secure properties for this environment ID, like for example, Sandbox, you see all the properties. You do require sudo control. I'll show you how to do all this in Ops Center. So it's still secure. Just be aware that if somebody gets credentials, they can certainly find out these properties that you've safely hidden. The secure properties stored in the files are supported in the Runtime Fabric. They're just the safely hidden properties are not. There's a question come from Govind. So let's go ahead and do a demonstration. What I'm going to show you is just how to secure configuration properties. Again, most of you are familiar with this. Show you how safely hidden properties work in Runtime Fabric, and we're going to go ahead and test out Edge Security and API Manager Policy. I'm going to spare you watching me deploy to Runtime Fabric. So trust me, we deployed this to Runtime Fabric, and I will show you all that. So I will go ahead and leave my screen here and pull up my trusty Anypoint platform. For those of you who have attended Denver meetups, you will know there's a tendency for us to use the Pokemon APIs. So I decided to adopt those for the Chicago meetup. So the requirement I'm dealing with right now is I do have my secure properties YAML file. And since I set this up last night, I know what my username is. My username is Big Compass. So let's just say in my properties file, I have user, which is Big Compass. And now I have a requirement to go ahead and secure Big Compass. We no longer want plain text usernames for the service accounts. As I mentioned, service accounts are generally provided for integration solutions. Those are typically going to have an awful lot of access. So probably the best practice is not to use that, have this out in plain text. So what I do to do that is I open up my handy dandy command prompt. In this case, it's going to be my DOS prompt because I'm happen to be running on Windows right now. I just go ahead and type in java-cp. This is the secure properties tool. I have to change directories. 1 second.
Hey, Brian, can you increase
Yeah.
the font of the command prompt if possible? There's
Oh yeah, I see what you're seeing too. Let's see. How about not sure if I could size this any differently. That's cursor size. Fonts. How about that?
I think it's better.
Okay, I could go even bigger. How's that?
Much better.
Okay. All right, so I gotta switch over to my bin directory. Okay, now I can go ahead and do my work here. So again, let's spell all that right. Secure properties tool, and then use my algorithm and my mode, which should match up with what I have entered in the secure properties configuration. And then I want my decryption key. Wait. Want my decryption key here. My value. That's going to go ahead and generate my encrypted properties. So all I need to do now is take this, put it back here. And again, make sure that let me go to my globals. Make sure that my secure properties configuration here, I did use Blowfish, I used CBC, I had the decryption key, and then make sure that the connector that's actually accessing this information is going to go ahead and be using the $, the secured double colon thing. I can go ahead and test this locally. And of course, since this is a demo, it's going to hit here and slowly, but basically it should work. The danger on what I'm doing here is that, there we go, it worked. The danger what I'm doing here is I put my decryption key into a global property to test this locally. So I better remember to take this out before I go ahead and enter this into any sort of version management tool. So what I've shown you basically is, again, using the secure properties and how you use them, how you put them into your properties YAML file, and how you can go ahead and test it out. So I talked about, oops, the other thing I want to show you quickly before I jump into these other consoles is, of course, for those of you who are using CloudHub or hybrid deployment, if I want to safely hide those, I'd put my secure properties, I'd put my decryption key into my safely hidden properties. So if we go over to Anypoint Management, I'm here. So actually, I just want to flip this guy over. If I go over to my Anypoint Management and I find the right application, which is going to be my database application here. And where to go here? Let me search for Pokemon. There we go. So if I go to my settings, and I look at my properties, sure enough, my decryption key is safely hidden. I cannot edit this. I have to basically delete this and re-enter this. So that works just fine with CloudHub. However, if I go over to my Runtime Fabric, which is what I'll do now. Actually, let me go back here. Go back to my applications, change my server to my Runtime Fabric. I'm going to call up unsafe Pokemon DB. If I go to my properties, you can see here, my decryption key is in complete plain text. So that's probably not an ideal solution. So how do we solve the problem? Well, we go into our Ops Center. And I'm going to have to go ahead and log into the Ops Center. Grab the password. Log in. I log into my server. You can see here we happen to have one controller node and two worker nodes. So what I'm going to do here is I'm going to do sudo root. Oops. Key I want to secure, what value I want to secure, which you saw me create a moment ago. And then which environment am I going to apply this to? So this is going to be my sandbox environment, because that is what my Runtime Fabric is associated with. So it's updated secure properties. So now if I go ahead and test against my safe Pokemon, which has already been deployed to Runtime Fabric, I get back to a German description of Ditto. Now, again, as I mentioned to you earlier, if I have access to this information and I just do sudo and I provide the environment ID, I see my key and value pair there. So just be aware of that. This is how you secure properties in Runtime Fabric. Just be aware, if I have the environment ID and if I have sufficient access, which I do here, I can get a list of all my keys. So just be aware of that, but it does work just fine. So I've talked about securing the properties. Let's go take a look at some policies. So for example, when we're doing the gateway policies, we're going to go ahead and use API Manager. So what I've done in the background is I have my Pokemon to DB application. I have the ID, which, as you all know, that's how you go ahead and map an application to API Manager using the auto discovery. although that's a different one, so I have a different one set up here. So basically what I would do here is I would go to my policies, contract policies gone. So I've disabled basic authentication, so I'll go ahead and enable it. While that is setting up, I'll show you what you do with Runtime Fabric edge policies. So we've talked about the edge policies within Runtime Fabric, which provides you basically WAF type of policies. So how do you go ahead and configure this? In my Runtime Fabric setup, or then my resource, my cores, how I'm handling my protocol, what domains, what keys I've provided. Here's where I can go ahead and configure here's where I can go ahead and use policies that I've configured. So where do I go configure those policies? I go into Anypoint Security. So we're at Anypoint Security side, we've configured a few policies. Let's take a look at some examples. The WAF has a series of rule sets, which include all these, including SQL injection. So Preston, Jeet, and I went back and forth a little bit on this yesterday. I'm like, wait a second, you support it at the WAF level. So you have your request rule sets, which applies to requests, and you have a response rule sets, which apply to responses coming back out. So what we did here, what I did here is, and I will test this out shortly, is I set up an allow list. You can see here, basically, I created a CEDAR address list to basically prevent something coming from my laptop. So let's go and test this out. So I already did my German Pokemon. I'm going to go ahead and send this again. Oh, I got request authentication, blah, 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 blah. That was caught by the gateway. You can see I sent back a 401 unauthorized. So what I'm going to do right now is I'm going to go to my security policies. Again, these are going to be applied at, once I find it, these are going to be applied at the overall Runtime Fabric level. So I'm going to go ahead and set my allow list. Remember, I already set up a CEDAR list basically to go ahead and allow certain IPs to access my Runtime Fabric, but not necessarily my CloudHub. It's going to take about a minute, is what I've been seeing. Trust me, it's not a New York minute either. It's like a West Coast minute. So you can see here, I'm still getting the registered authentication. So my WAF policy hasn't deployed yet. And now I could not get response at all. So I'm getting blocked at the edge. Can't even get my request in there. Just for grins, I have this deployed also to CloudHub. You can see here, it failed against the API manager policy, but of course there's no edge security to CloudHub, so it got through to that. So hopefully that made a lot more sense now. So what I've done, just to recap in my demo, is you saw how I locally encrypted a property, how I tested it from the connector, which of course, just be aware, I also had to provide my key in order to test from a connector. I showed you safely hidden properties on CloudHub. I showed you the difference between CloudHub, and it should really be CloudHub and hybrid, and how it works as Runtime Fabric. I applied an API manager policy to both my CloudHub deployment and my Runtime Fabric deployment. Should do that work. And then I showed you my edge security policy. What I didn't show you, and I'll take just one more minute to show you that, is what does a custom policy look like what does the custom policy look like? So this is what we've been working on. Can you see this that well? Or does this need to get blown up a little bit more? All right, I'll just quickly get through this. So basically what this custom policy has is we have two parts to it. We have a request. We're routing the request information to the server that's going to receive the request. If we get back an exception, this is error handling. We also have a second part of our policy, which is called the response policy, where we're rerouting the response back to the server. So this is, although I'm looking at this in Anypoint platform, this isn't, in Anypoint Studio. This isn't an Anypoint Studio application. but it looks a lot like the XML you would create. So basically, you can't graphically edit it. You have to go ahead and edit the XML by hand. So this is an example of a custom policy that you can provide, apply at the API manager level to basically handle the so-called zero trust. Of course, here we're working with a vendor who has the server that's going to go ahead and receive this information and apply its AI to it to figure out if it looks okay or not. So now I really did show you the custom policy for the AI/ML solution. So I'm going to go right now. It's time for me to wrap up with a trivia question. So what is the most secure way to hide sensitive configuration properties? Your answers are I see here there's a lot of different answers here, so I will go through them. Secure configuration properties. That's a good way to do it. However, there are some people that have heartburn over putting any of these properties into your version management solution. So if you put into GitHub, okay, they're there. Somebody gets a hold of the key. There you go. They can just decrypt all your properties. Runtime Fabric, safely hidden properties. Again, you saw that I had to go ahead and create by the command line, which is fine, but I have to give somebody access to my Runtime Fabric instance who may not necessarily shouldn't normally have access to that in order to enter properties, or I'm giving properties to somebody else to go ahead and enter them into Runtime Fabric. CloudHub safely hidden properties, those are certainly encrypted at rest. That is a good way to do it for CloudHub and hybrid applications. The best way to do it is to actually inject these properties during continuous deployment. So some customers will keep their properties either in their CD tool. I've seen this done with Azure DevOps. I know some people use vaults and they inject these properties during the deployment process. Again, just be aware if you're safely hidden, if you're going to use safely hidden properties and you're deploying to Runtime Fabric, they're going to show up in plain text. But D is the answer. And with that, I will turn it back over to Connor to talk about tokenization and one last demo.
Thank you, Brian. Okay. So tokenization. What exactly is tokenization? It's similar to hashing or encryption, where you're trying to obfuscate or protect sensitive data. The main benefit of tokenization versus something like encryption is that tokenization is format preserving. So looking at the diagram, if you have something like a credit card number coming in, your tokenization policy is going to pass it to the tokenization service, and it's going to return a non-sensitive token that is intrinsically has no exploitable value, but it looks exactly like a credit card number. It's in the same format. And so this is going to reduce any changes that you might need to make on downstream systems. It's important to note that the tokenization service does not come with RTF installations by default. The service must be configured. In the configuration, you're going to specify which token formats you're going to support, and then you have to deploy it to the specific target RTF instance. It's reversible only through the detokenization policy. It's vaultless, meaning even if a bad actor does get access to your RTF instance, they're not going to find a lookup table or any database where these original sensitive credit card numbers are stored in plain text. It's highly scalable. Whether you're provisioning more resources horizontally or vertically, you're going to see linear performance gains. It's highly flexible, particularly in the formats it supports. So MuleSoft provides several formats out of the box. These include things such as credit card numbers and social security numbers. If you want a credit card number to be validated to ensure that it is a real credit card number, you can set that up there. Additional flexibilities include things like masking. So if you want to mask all the bits but preserve the last four, you can do so, as well as just preserving them. So something like a social security number, if you want the beginning digits to be tokenized and then the last four to be preserved, you can do so. So how exactly do you apply it? You have to deploy a proxy API to your Runtime Fabric, and then that proxy API, you're going to set up a tokenization policy through API Manager. When you're setting up the tokenization policy, you're going to configure a selector expression, and that's just a data weave expression saying which fields to tokenize. It's important to note that only information in the payload or the request body can be tokenized. As of now, query parameters or headers are not supported. But with that selector expression, whether it's nested deep within an object of your request body or the entire payload, you can tokenize that. It's configurable in terms of the request or response. We'll see that a bit in the demo, where if you want the tokenization to happen by the policy on the incoming request before it's passed to the backend Mule application, you can do so. Or if you want something in the response body of the Mule application behind the proxy API to be tokenized, you can do so. For every field you want to tokenize, you're going to specify which format should be applied to that. And again, those formats were defined when you were deploying or setting up the tokenization service and deploying it to your Runtime Fabric instance. To kind of tee up the demo, I'd like to highlight a good use case for tokenization. So let's say that we have an orders API, and coming out of the orders API are credit card numbers and the charges associated with that credit card number. So the sensitive credit card number is going to hit your tokenization proxy API. It's going to immediately pass it to the tokenization service, and it's going to get back a credit card token. Again, it's going to be the exact same format as a credit card number, except it has no exploitable value. You can safely expose this to downstream systems or other lines of business, such as your finance teams. But what we're doing here is we're passing it to our credit card tracking app, or our charges tracking app. And it's going to insert it into the ledger or update the ledger. So the ledger has all of the tokenized credit card numbers and the aggregate sum of the charges associated with that. Again, this ledger can be exposed to anyone. It's not vulnerable. So if your finance team wants to draw insights or run queries on this ledger, you can safely expose it to them. This ledger can also be exposed to your payment processor. And so whether it's on a fixed frequency or after a certain dollar amount, let's say your payment processor is going to execute the sum charges on that card number. They'll send a request to the detokenization proxy API, and you only want your payment processor to have access to the detokenization policy or proxy, because that is the only way to get back to the plain text value. The main difference between the tokenization proxy as well as the detokenization proxy, other than one being tokenization and the other being detokenization, is that the detokenization proxy API in the bottom right here is going to detokenize on the response, not the incoming request. So the payment processor sends the request with the card token. The proxy API is going to pass that to your payment tracking app. And again, this is dealing with non-sensitive information, and it can be used for auditing or alerting. And then when the response is sent to your payment processor, the detokenizing proxy policy is going to detokenize and return that original credit card number to your payment processor, where they can then execute the charge. So in the demo, what we're going to see is these tokenization and detokenization policies and actions. But what we're not going to cover is the tokenization service configuration and deployment. So, well, I think it's, okay, there we go. So here's our ledger. Sorry, my mouse keeps not working. One second. One sec, my mouse just stopped working.
We don't have any of these problems when we do in-person meetups. It's just always remote meetups.
There have been other problems though with the presenter not, projector not coming up. I can remember. Yeah.
Okay. Sorry about that. I'd open my computer and using the trackpad now. But this is our ledger. If we run a query, we see that this card number has the total charges of 500. if we switch over to Postman and we're sending this to the tokenization policy. And so we have our plain text credit card number, and this is the actual card number and the charge associated with that. So we're going to send it, and we see that it was successfully tokenized to this value. And if we switch back over to our ledger, we can see that the total charges was updated. And now let's say $550 is the amount that our payment processor is set to execute the charges. So the payment processor is going to pull from this database the tokenized card value as well as the charges. And it's going to send it to the detokenization proxy. So now we have our card token. We send it to the detokenization policy. That payment tracking app can audit this charge as being executed or send an alert that it's being executed. And what the payment processor receives back is the original plain text credit card number. Again, we do, I believe, still have that web application firewall active. So if we try to do anything nefarious, such as reading from the ledger, if there's any SQL in the header or in the query parameters, that web application firewall, oh, Brian, was it turned off?
Yes, I turned it off. I could turn it on. We still have a minute when we activate the WAF, right? WAF 2, WAF 2 or WAF?
I
think WAF got it off.
Protection.
Huh? What's that?
Whichever one has the SQL injection protection.
I think WAF does all of it. So you'll just have to wait a minute. Talk amongst yourselves for a minute. I'll just double check that while it's doing its thing here. Yeah, request rule sets, it should detect and reject it. You may have to give it about a minute or two. Did I deploy that? Yeah, I did do that, yeah.
How long ago was it deployed?
About a minute. There you go.
So that one, the cross-site scripting attack was rejected. So this one's working now. Yeah, so we get the 400 bad requests, and we see that the web application firewall did reject it at the edge. And then switching back to the final trivia question. Which of the following is false? And the answer is C. The RTF installation does not include the tokenization service by default. Again, it has to be configured and deployed from Anypoint platform. That concludes my presentation and demo.
I think that's all we have. Preston G, I'm just going to double check to make sure. Yeah, that's it.
Yeah, thank you. And I think it was a great presentation. Thank you, Big Compass. Thank you, Brian and Connor, for leading the demo and also the presentation. I'm sure you know, the audience have thoroughly enjoyed the conversation. There were some questions in the chat. I think there was one question that, you know, Brian, I'd probably try to get your response. And I think then we are good to go. And so the question was from Ikran. It was about how can you edit the hidden properties from RTF CTL?
I believe the answer is you have to delete it and then redo it. I haven't tried it. I could, I'll try it in the background though. Oh, goodness gracious. I haven't tried that. I think it's similar in concept to CloudHub that you can't edit, but I could just quickly try it. I'd probably have to go find, because I know you can only do get and apply. I don't know if there's a command to do the other one. I could get back to him actually, if that's better.
Sure, no problem. Thank you so much. And thank you for presenting on the Chicago Meetup. And thank you everyone for attending the Meetup. This time, I think the recording went well, and unlike the last one. And so hopefully with Big Compass permission, I'll see if we want to, put that in a Meetup session. Until that, look forward to see you in the next Meetup. Thank you.
Thanks, everybody.
Yeah.